This video is about using SchemeIt to draw schematic diagrams. It doesn't really correspond to anything directly in the Applied Analog Electronics textbook, but it probably should be viewed at about the same time as section 7.10.3, which is the section introducing schematics. Okay. You may remember from a previous video that we have several different symbols available for drawing schematics. For this example, I'm just going to use a few of those. And in fact, the schematic I'm going to try and draw is the one that I've been using here as a background. Now, this schematic that I'm going to draw is not going to include the screaming mouth, because that is not something that SchemeIt can do. I put that in afterwards, and I'm not going to be showing that. So we're going to be taking these symbols and putting them in the schematic with SchemeIt. SchemeIt is a tool that's provided by the DigiKey company. It's a free tool, and I like free. And the way they monetize this is that they've provided connections to their catalog of parts. They are a parts distributor, and so if they can convince you to connect your schematic diagram to their catalog, it's to their advantage. And this way of monetizing it means that it's likely to stay free, unlike a lot of other tools that I've tried using on the web, which were free for a while, and then suddenly they decided, hey, we're not making any money, we're going to start charging subscription now that we've got people sort of locked into using our tool. I'm hoping that DigiKey never goes there. This isn't a plug for DigiKey, by the way, though I will admit that I do use their parts catalog a fair amount because it has the nicest parametric search capabilities of any of the distributors. They don't always have the best prices, but they have the best website. Okay, so using SchemeIt. I'm not going to be using the catalog connection for the sorts of stuff we do in this class. What we're going to use is primarily the schematic symbols, and occasionally the diagram symbol. And if you end up with something where you cannot find a symbol that does what you want to draw something that they don't provide a symbol for, you can build your own symbol up here. And some people do that. We don't really need to do it in this course, but if you decide, hey, I want to represent this symbol and it doesn't exist, that's where you would do it. Actually, there is one place in the course you might want to do it. They don't have a good pressure sensor symbol. And so if you want to draw a symbol for the pressure sensor, you can build your own symbol up here. But for now, we're going to just use standard symbols. One thing. There's one thing in the diagram symbols that we do use, and that's under basic shapes. We use a label. So if you need to put a title or a date or something like that on your schematic, title, date, you can put any sort of text there, and you can play around with the size of it and whether it's bold or italic, and you can even change the color. So let's make this sort of orangey. Okay, so we have orange text on there. Don't do orange text; it's really hard to read. Okay, but that's the only one of the diagram symbols that you are likely to ever need. I guess sometimes you can draw a rectangle around things and move it to the back so you can outline some stuff, but for the most part, forget about the diagram symbols. Schematic symbols are what you're going to be using. And the diagram that I was trying to draw, that backdrop I've been using, had an amplifier and a bunch of ports and a couple of resistors. So let's start with the amplifier. There's a bunch of different amplifiers here, and they all look kind of the same. Which one do we pick? Well, advice that I gave in an earlier video was that because there's a tendency for students to forget to connect up power and ground to their amplifiers, it's a good idea for your schematic diagram to remind you. So we want one of the ones that has power and ground connections. So that gets rid of half of them. And we're doing design in this class where everything is single power supply. We're using like 0 and 3.3 volts, not plus or minus 5 volts. You can have dual supply designs where you have a symmetric pair of power supplies, and that's a more expensive design. It does get used a lot in analog design, but we're not doing that. So we're going to look at just a single supply op amp. There it is. And I would like to be able to put a part number down here, but for some reason they've disabled that. It used to work just fine. I don't really need a name for an op amp, but I can give this, I can use the name up here, MCP 6004 is the op amp we usually use in the class. And it's got a name here. I find it useful to put that name inside rather than out in the corner. And I don't really like that U1. If I only got one in my system, I don't really need to indicate that it's number 1. So I can just sort of hide the reference designated. So there's my amplifier with power supply, except for I haven't hooked the power supply up yet. Maybe that's the thing to do next, since it's the thing students forget most often. Let's take care of that first. All right, so we go back to schematic symbols over here, and power supply is done with ports. So we go and look for ports. And there's a whole bunch of grounds. And you may remember from the previous video that we do not use the earth ground. We do not use the chassis ground. Those are not grounds that we have in our system. Our system has a generic isolated ground. So we'll use that one. And I put it in here. I don't really need the reference designator, so let's kill that. Hide the name. It doesn't really need a name. The symbols only ever use a ground. And incidentally, the ground symbol points down. You do not rotate this ground symbol. It always points down. Leave it alone. And I can just grab that, click on the tip of the wire here, drag it up to here, and now those are connected. And that connection is one that it remembers. It's actually a semantically meaningful wire. It knows that those two things are connected together. I can move this around with a mouse. I can also use the arrow keys, which for fine movement on the grid is often easier. Okay, so I've got the ground. Now I want to do the power. And if I go down here and look, there's a whole bunch of power ports with different fancy names. I never use any of those because after I complained about it to them for about a year, they finally got around to giving me one on page 3 here, which doesn't have a built-in name, and I can give it whatever name I want. So if I say, hey, I want to call this thing 3.3 volts, I can do that. And it's 3.3 volts, and I don't want the reference designator, so click on that twice to get rid of it. They, by default, always show you the reference designator, even though they haven't shown it. Clicked on the checkbox here. And there's a temptation to just sort of put these next to each other, but they're not then connected. If I move this amplifier around, the ground stays connected, but this one didn't. So undo that, move this back up a little bit, connect them by dragging a wire from one to the other. And now, if I move this thing around, it knows they're connected. So make those connections, even if it looks like the same thing, when you just overlap wires without having them touch, it isn't the same thing. Okay, now I had some other ports. What other ports did I have? Well, I had inputs and outputs. And notice that there's sort of the double arrow ones and the single arrow ones. I only ever use the single arrow ones. The double arrow ones sometimes get used when you're indicating I've got a multi-page schematic and this is going to outside the multi-page schematic, whereas the single one is connection within the multi-page one. You're not going to be doing multi-page schematics very much. All your stuff's going to be sort of one system, so we can get by with just using a couple input pins. Port 1 and port 2 are not that great of names. In fact, those are reference designators, not names. So let's change that. Let's get rid of the reference designator, give it a name, and let's call this one VM, because I think that's the name I used in the backdrop. And there it is. All right, and this one, again, get rid of the reference designator, give it a name, and call it VP. and I actually have to click away from there before the text actually changes. Now, if I remember it on the circuit correctly, VP just connected up to the positive thing here, and I just drag and click. It looks a little awkward there being off by 1, so let's lower it. And now for VM, it didn't connect directly up to the minus sign here. There was a resistor in the way, so I got to find the resistors. The resistors are under passives. That's where we're going to have capacitors, inductors, resistors, all those different things. I can just click on resistors, and there it is. Notice they have the American symbol and they have the European symbol. The European symbol is just a rectangular box, and it's not nearly as distinctive, so I don't use it. Let's use a general resistor here. And when we drag it on here, we see there's a problem. I wanted a horizontal resistor. This one's vertical. Well, if I go over to Object Properties, I can rotate it, and now it's horizontal. So coming back over here, picking it up, putting it where I want it, hooking it up, hooking the other end up to the input. VM there should be one higher to line up nicely. Just use the arrow key to move it up one. For large motions, the mouse is usually easier. For small motions, I find the arrow keys, just moving up one, right one, that sort of thing, is easier to do often with the arrow keys. All right, I had 2 more things here. I needed another resistor that came from the output back to the negative input, because this is a negative feedback amplifier. That's where it goes. So I need to pick up another resistor. And again, it needs to be rotated. So rotate that and place it where I want it. Maybe move this ground up a little bit to squish things together a little bit. And now I can hook this up to, oh, I don't like the way that it wants to run that wire. What I can do here is I can click to drop a corner where I want it, and now it's running this thing properly. Instead of going up and across, it's now going across and up. And I can do the same thing over here. I have to do the same thing of click, and when I hit this wire, notice it lights up the wire. I click there, and if you look at what it's done here, it's put a connection dot there. See that circular dot? That's indicating these wires are connected. They're not just running past each other. I mean, I could have taken something from here and run it over to here, and it crosses those other lines without making a connection. And now, because I haven't got anything over here to connect to, it's not something that I can do. Just get rid of all that. But if you want things to be connected, there must be a connection dot. Missing that connection dot would indicate, well, since it's a T connection, it's not a serious problem for the connection dot to be missing. But if it was a crossing line, 2 wires crossing each other just like that are crossing, they're not touching. You want them to connect, you have to put that circular dot there. Very important when you're doing it by hand too, because it's very easy to have things that are close but aren't supposed to be connected, close but they're actually supposed to be touching and connected. Put the connection dot in if you really need a connection. Now this diagram's almost done. Couple problems. I don't have an output port. So let's go back to ports and find an output port. And if you just sort of scroll down here, no output ports on the first page. Ah, there it is on the second page. Grab the output port, plop it down. It's pointing the wrong way. Why did they point it the wrong way? Outputs go to the right, they don't go to the left. All right, but we can go over to Object Properties and do a horizontal flip on it, and now it points the right way. Don't know why they didn't draw it the right way in the first place, but it's easy enough to fix. And now I want to hook this thing up to here. And notice again, it put in the connection dot for me. Oh, I don't like the name port 3. Let's go and fix that also. Turn off the reference designator, give it a name, and I believe we called this one vout on the original. And make sure that the name becomes visible. I don't like where it put the name. Let's put the name over here. You can drag that around. R1 and R2, other problem, and this is a serious problem that you'll have in a lot of your designs. Every component needs to have a value or a part number. Now for resistors, we just care about their values usually. For the op amp here, I put on the part number. I'd like to know what are R1 and R2. And if I click on this one, notice it's already got a checkbox here for value, but the value is blank. If that one was supposed to be 100 kilo ohms, I can make it 100 kilo ohms there, and then I have to click somewhere else to make it actually appear. Don't like where it put it, but I can move that there. And now it's got both a name and a value. Now, sometimes when you're doing early stages of design, you can say, I want a negative feedback over here, but I don't know the values yet. And so you just have names R1, R2. In your final schematics, the ones that you use to build from, put the values in. Because large fraction of the errors that I see students making in their labs when they do the design is they put in a different component value than what they intended to. They intended to put in 100 kilo ohms and they put in 100 ohms. Or they changed their mind at some point and they were going to do 100 kilo ohms, but later on they changed their mind and decided to do 2.2 kilo ohms. The schematic says one thing, the circuit says something different. I say, oh, here's your problem. You got a 2.2 kilo ohm resistor here and it says you're supposed to have 100 kilo ohm resistor. Oh, we changed our mind. I can't help you debug if you make things up in your head and don't put it down on the paper. You have to have your schematic being the thing you're trying to build. If you change what you're trying to build, change the damn schematic. I have to yell at you now for that to avoid yelling at you in lab for that, because it is such a common problem for people to think that I can read their minds, that I know what they're trying to design, and that I know their design better than they do. Show me the schematic. If it's not on the schematic, it ain't fucking designed. Okay, one more thing. I want to get rid of this stupid title. There. Here's our design. We can save it. And what you do is you give a project name here, and it saves it on the DigiKey site underneath your login. And I will just call this something silly like video example. You might want to name it after its function or after the homework that it's part of. And now it's saved it. But having it saved on the DigiKey site doesn't help much when you're creating your reports, because you can't include the entire internet or the entire DigiKey website in your report. So you need to do something else here, and that is you need to export it. And you can export it in several forms. The KiCad one, that's for doing print circuit board design. We don't do that in this class. You can do image in PNG format. Don't use PNG. These are line drawings. Don't use a raster format for line drawings. They get fuzzy. They're really hard to read. Use the PDF format. And what you want to do is active area, no size, so that then you have a bounding box that just goes around your object. And that's what you want to export. Now, I actually did something slightly different in the book. I exported everything in support vector graphics, and again, just the active area. And then I converted these support vector graphics to PDF. Why did I take the extra step? Well, it turns out that in PDF format, occasionally they get the margins wrong. And you get a little bit of white space that you didn't want, or it cuts off some text that ran off the edge. So I have given up on using their PDF thing, and I do support vector graphics output, and then I use Inkscape to do the translation. I mentioned how to do this in the book. But you can do the PDF, and if you don't fuss about it too much, it's usually good enough. So export that, and it'll ask where you want it to export it to. Here it's bringing up preview, because it actually exported it directly to my downloads file. Okay. That's really about it. It takes a little practice to get used to using SchemeIt, but it's not a difficult tool to use for drawing. It produces much nicer looking schematics than many of the other tools that are available for drawing schematics. And it produces them, you can get them directly in SVG and PDF formats, which can then be incorporated into other documents. So it's a decent tool, and the price is a good one, free. Okay. Have fun practicing with SchemeIt, and use it for, or something at least as good, for all the schematics that you produce for this course.